Yeah. All right. How's it going, everyone? Good? Excellent. So let's start off today with just a little bit of review of what we did yesterday. By the way, in your books, or in the online book, we're in chapter 2 and 3 right now. I forgot to mention that yesterday, but if you're reading along in the book, that's where we're at. So everything you type into Python, all the data you put in is an object, right? We talked about it being an object-oriented language. So every object has a type or class associated with it. What's the type of this one? String. That one. What was that? Integer. And then float. Perfect. String, integer, float. And you can convert between them by using little conversion functions in Python called stir, int, and float. So if you say int 2, you get back, right? Or you say, oh yeah, int, and then like the string version of 2, you get back the number 2 out of string. Stuff like that. So you can convert, there's types, they're great, they're awesome. So I wanted to be clear about the variable pointers business over yesterday because we talked about variables a little bit, and I drew you a little picture of how the variables look inside of the computer, where you have these boxes and you see something like x points to 12. Now, I drew a bunch of stuff where I was like, well, if you set y equal to x, and then you suddenly start to like mess around with 12, things get weird, or if you mess around with x, things get weird. This might have been pretty confusing, and I think I kind of bungled that up a little bit. When you assign something like y equals x, when you assign variables to other variables, weird stuff starts to happen, especially when you get into like changeable data types like lists and dictionaries. But you're only going to go over that in like 3 weeks. Okay, so it's like not happening right now. So really, all you need to know is that when you assign a variable in the computer, this is what happens. It takes the variable name and points it towards the actual data. This will be important in 3 weeks, but for now, this is what you need to know. Okay, let's review the shell and then we'll get going. Let's do a quick little review of taking input and printing it out. I want to ask a user their age and then print that age back out to them. Just a simple little echo action going on. So let's get some volunteers. What do I want to do first if I want to ask the user their age and then print it back out to them? What's the first thing I need to do? Volunteers, ladies and gentlemen. You assign a variable. We'll call it age. We want to ask the user what their age is. So we want to ask for input. How do we ask for input? Input, and then what?
Hi, what's your age?
Hi. What's your age? Okay. Let's do 342. That's 30,042. That's just fine. Okay, so we've got the age now. Now what do we have to do? We want to print to the user, right? So something like print cool, your age is plus what? Plus age. Excellent. Good. That works, right? if we had assigned age to the actual number 3042, this same command wouldn't have worked, right? And that's because when you ask for input, it always returns a string. Always returns a string. So the type of age that got returned here when we asked the user for their age wasn't a number anymore. It was a string that we could use when printing out. If it's the actual int we're talking about, then we're going to errors. Type conversion input, very cool. Okay, so today we did the shell yesterday, and it looks kind of confusing when you type it all out because you're trying to write programs and do stuff with the computer that's like one after the other, right? You're trying to say like do this and then this and then this, but in the shell you have to type it in one at a time, and it's really lame. So today we're going to go over scripting, which is what allows us to write our program line by line by line, just like we did in Scratch, where you put your little blocks one after the other, and then it executed them in that order, right? That's what we're going to be doing with scripting here. And in particular, we're going to try and write some scripts to solve the Drake equation for us. We're going to ask the user a little bit of information about the Drake equation, and then we're going to try and solve it for them and show them the results of this magnificent equation. It tells us all about terrestrials and life out there in space. So let's get into scripting. So Scratch, you couldn't get any errors, right? Scratch, it always ran the program, and there was never any red text anywhere. Nothing ever broke. But in Python, we get all of these errors when things go wrong. Like if we're trying to use an int as a string, if we have a syntax sort of thing, things break, right? And when you're scripting, like in Scratch, you had your blocks, right? And in Python, you'll have lines of code. You'll have your lines line after line. If your program breaks in the middle of your program, it doesn't just keep trying to run. It just stops wherever it breaks. So it's really important for programmers to know where exactly our program broke so we can fix the problem. So we can find the specific line in our program that it broke. Because you can imagine having 100 lines of code written down, and you need to find the one line in your program that's breaking the thing. This is the whole process of debugging. You've got to find the error, fix it, and then make sure your program runs the way you expect it to. Now, there were 3 types of errors we were talking about 2 days ago, or maybe it was 3 days ago with Dr. Godrich. Let's see if we can remember those. Let's see if we have anyone with good memory in here. There were 3 types of errors. Let's get one of them. Just say it out. Syntax. I have really bad handwriting. Runtime. And semantic. Beautiful. Syntax errors will get caught right in Python. These will get caught before your program even tries to run. Python will look at your program that you've written and be like, this doesn't look right. And it just won't even try and execute. Runtime happens while the program is running. The program will try and run, and it will break somewhere in the middle, and it's going to throw an error. Semantic errors will not throw any red text at you. Python doesn't know semantic errors. Semantic errors you'll find out when you run the program and the wrong output shows up, or something weird happens that you didn't want to happen. So let's take a look at these in the form of a script I wrote a little bit earlier. Okay, so I have a script here. It's called ageasker.py, and it doesn't really look like a Scratch file, but you see the code here. It's written line by line, just like you did in Scratch. It executes line 1, then line 2, line 3, line 4, line 5, line 6, line 7, and it does them in order. This particular program knows my age, and it prints that age out to the user, asks for the user's age, and then it does a little calculation with our ages, and prints out the result back to the user. So pretty simple, pretty straightforward. You could imagine writing this in the shell, just going through line by line, but here we just have them all condensed together. And when I execute this, Python is going to try and do just that. It's going to send all of these commands over to the shell and execute them one at a time straight down the line. So let's try and do that. We do this by going over here into the Run tab, and we'll do Run Module. I usually just use F5 because it's a lot quicker than clicking on things. Notice also that there's two windows open right now. There's like the shell back here in the background, and then there's the actual script file over here. I just have them overlaid in full screen because my screen's really small. Okay, so I'm gonna hit F5 here, and bam. We've got a pretty clear sign that I've got a syntax error because it says right here, syntax error. That one was easy. So I've got a syntax error somewhere. I click OK, and it's gonna highlight some stuff in red text for me. Python does not highlight your syntax errors. It does not highlight where your syntax error is. It highlights the first thing that breaks around your syntax error. It reads in your file and it highlights the first thing it breaks. This is not necessarily where your error is. It's just the first thing that breaks. So what's happened here is it's gone to the first line, my age equals 22, looks fine. It does the next line and it keeps reading, and it gets to age here and it doesn't know what to do with age. So let's get some volunteers. Where is the bug? Let's hear from someone who hasn't talked. Yeah. Right here? Yes. Got to close those parents. That's a syntax error. I was just missing a parentheses there. So let's try and run this again. Okay, we get somewhere. I'm 22. Let's say this guy's 25. Oop. Okay. What kind of error did we get this time? Which one of these errors did we get? Yeah, runtime error. We were in the middle of program execution and it broke on us. Specifically, a type error. Can't convert int object to string implicitly. Now, there's another very important piece of information in this error. Right here. When you get runtime, sorry, I should probably turn the light on. When you get runtime errors, Python knows exactly which line your program broke at. It knows exactly where it stopped running, and it's going to tell you. And it tells you right here, the file ageasker.py in line 4. So now we can go back to our code and take a look at line 1, 2, 3, 4. So this is the line that broke. Why did it break? Yeah? Exactly. So what? So which one of these is the what's the problem here? Yes. Age is a string there, and I need to convert it to an int. We got a little clue hint there by the error it gave us too. It told us the line it was in, and it also told us that it was having trouble converting an int to a string, right? So we kind of knew that it was like a conversion error, and we knew that it was at this line. Pretty easy to set up right there, and we can just get that in there. Okay, got that solved out. Okay, let's try 25 again. Woo. Good. I do have a semantic error. What's the semantic error here? Yeah, that doesn't make any sense. Okay, so that's not right. What's the problem? Yeah.
You need to go to the final line, and you need to convert it to new my age instead of new age.
Ah, yes. I was using the wrong variable there. Yeah.
Also, you should probably change that my age from the 5th line down to end my age.
This one?
Yeah.
This one is already in it.
Oh.
I've assigned it to an integer here. So I think that one should be fine. And it wasn't having any problems printing it out over here. So we should be fine there with the types. But yeah, so I used to have this new age, and it was just the wrong variable name. I did some quick copying and pasting, and I messed it up. So let's try this one last time. Let's see if we can get it. All right. Look good? All right. So these are the basics of how you're going to be debugging with scripts. You have to write your script in a separate file, and you're just going to be running it, see what errors show up. Syntax, runtime, semantic, and then you're going to be trying to use the clues that the program or Python gives you with error messages, where it highlights things, or just what exactly was going wrong in your program. And you have to figure out what line, where in this script is the problem, and how can I fix it. So that is that. Let's get on to actually writing some stuff and doing something interesting, shall we? Can everyone sort of read this? Can sort of see the text even in the back? Good. This is the Drake equation right here at the top. N equals R times FP. This little stop over here. N equals R times FP times P times FL times FI times FC times L. So we've got this equation, the Drake equation. It tells us N, the number of civilizations in our galaxy, which we might be able to radio communicate with. But the idea here is, okay, scientists, give us all of these. If you can figure out all of these and give us numbers for all of these, the Drake equation will tell you the amount of civilizations that we might be able to communicate with. Basically, the amount of intelligent civilizations that we can work with. So this seems like a prime example for writing a script for. Scientists are going to be trying a bunch of different numbers into here, and it's going to be really annoying if they have to do this by hand over and over again. It would be really helpful if we could write a program that would just ask the scientists, okay, what's R? Good. What's FP? What's NE? What's blah, blah, blah? Okay, you gave me all of that. Here's the result. Here's what the Drake equation gives back to us. Maybe we could even be nice to them, explain the Drake equation a little bit while we're at it. And that's going to be our goal today. And we're going to do this all in a script, because this would be a lot to write down in the Python shell. So you can go ahead, open up idle. Everyone should go and create a new file. When you open up the shell, you can create a new script by going up to File, New File, and it will pull up a blank little page for you. I suggest saving it first so that you can give it a name, because it just starts as untitled. So you can start by giving a name. I'm just going to call mine Drake. Also, keep note of where it's saving it to in your computer so you can find it later. So you're going to write scripts. You would write code in the shell, except you're going to write it all at once, and you're going to run it all at once. So it's a good idea when you're starting to write a script to start with a plan. To start with a plan for your code and how it's going to execute. When we're in computer science and we're making a plan that's not exactly code, but it sort of tells us how the code is going to work. We call that pseudocode. We call sort of making and sort of writing your code in English before you actually write it in a language that the computer understands. We call that pseudocode. And it's a good idea to start with that before you start writing your script. So you can start by writing things. First, I'm going like first ask, oh, let's do first tell the user about the Drake equation. Okay, straight enough. And then next, ask the user for, what's the first one? What's the first variable here? Ask the user for R, right? And then so on and so forth. We'll keep writing out what we want this program to do. And what's this program going to do at the end? What's going to be sort of the final result? Yeah, print out n to the user, right? Print n to user. Okay. You can see that this text up here is sort of lighting up in different areas and sort of acting a little strangely. That's because Python thinks this is code that you're trying to write in right now. It's thinking like he's writing some commands for me to run. But obviously, if you run this, it's just going to be like, what are you talking about? This is gibberish. And of course, it is gibberish to the computer. English is gibberish to the computer. So we have to tell Python, look, don't worry about all this. This is just me talking to myself. And we tell Python that by using this little pound symbol. This marks lines as comment lines. And Python will ignore these lines while it's running this file. So I'm going to go ahead and comment out these lines. If you want to be real quick, you can use Alt-3 to comment out your lines for you. 1 pound sign, 2 pound signs, it's all the same to Python. So that's how you can write comments, and you can start to create a plan, write some pseudocode for this Drake equation that we're trying to solve here. And this is going to be our job for the next little portion of class. I just want to start off with the first line of code in this program, and then I'll let you guys work on the rest. So we start off with like a statement of this is the like Drake equation, right? Do more than this, explain more to the person than just like, this is the Drake equation. Yeah, it's great. Tell them what you're trying to solve, what this thing is going to do for them. Like, let them know what's going on. And then what are we going to do after that? What's sort of the first thing we need to do to start computing this Drake equation? We want to start computing this Drake equation. What's the first thing we need to do? Let's hear from someone. This area of the room is sort of quiet. It's a real cool area. What's the first thing we need to get? What's the first thing, if you were a mathematician trying to solve this equation for n, what's the first thing you need to know? What do you need to get so that you can solve this equation? Yeah, all the variables, right? And which is the first one of those variables? R. Okay, so we need to get R. We need to know what R is. And the user is going to tell us. So what do we need to write? Right? R equals some variable equals input from the user. Give me the info. right? Follow the pseudocode that you write. First, we tell the user about the Drake equation. Next, ask the user for R. And then what happens next? Finally, you'll get to a final print statement of your final result. All right, let's spend, I think guys should be able to get this done. So take some time in class here, work on it, talk with the people next to you about what needs to happen, write good pseudocode, and solve the Drake equation for your users. Yes, sorry. There you go. I'll be walking around, raising questions, all that jazz. And when you get the program running, eventually, you can just put in numbers that you think make sense for all of the stuff. Yeah. Doesn't it?
You can Google how many stars there are in the universe and how old the universe is.
This is really more of a programming exercise. Yeah. Get the equations, go out and do And remember, you don't have to finish the entire script before you try and run it. You can run the script at any time to see if what you've got so far works. That's usually a pretty good idea. Write a few lines and then run it to see if the stuff you've got works. And keep writing. Yeah.
For L, what is the unit we'll be using?
The length of time for which such release detectable signals into space. I'm assuming that's like years of time, years of time that they're like
They've been broadcast.
Yeah. Like human broadcasting for what, like a couple hundred years or something?
Something like that.
And we're gonna stop broadcasting in like 1,000 years, maybe, whenever our civilization dies. I think when we've got a few people done, we'll Google search logical numbers to put into the Drake equation. See if we can get real results.
When we start a new line, it'll like indent it. Does that matter that it indents it, or do we want
Yeah. Python really cares about white space. It really, really cares about white space. If Python indented something for you and you didn't think it should be indented, you're probably doing something wrong, or there's probably a syntax error somewhere. Just I would say run it and see what happens, and see if something weird happens. Yes. Tabs and new lines in Python mean a lot. And if you're wondering if one particular line in your code works the way you kind of, you can always just run it in the shell sort of off to the side. If you're wondering like, oh, well, does this input statement work? Like, is my math correct here? Are the types of things that I expect them to be? You can just pop into the shell and check real fast. Python's really great for that. Just go into the shell, check it, and go back to writing code. Yeah. So right now things they're all strings. The things you kind of multiply a series of strings. Really, two strings together, string. Should be or if they're, I mean, it depends if they're interpolating. Yeah. Because yeah, if the user tries to put in something like a fraction and you convert it in straight away, that's no good. You want to keep it as a fraction. That's what they're putting in. Yeah, so oh, let's look at that's right after. Okay, not happening. Did you try copying and pasting this into the shell and that's what all this goes? Yeah, okay. That doesn't. That's why you're trying to do multiple statements in one line of the shell. You got to use the run module button to put in your number. Yes. Let me just see. Okay. The answer to be 2 times. Now you got a line number and then here. And about that.
So now that you have the variables, so that
Exactly. Exactly. Or float, depending on what you're asking. Are you asking for a whole number or are you asking for a fraction? So each one might be a little different. Or you, honestly, to be safe, you could just convert them all to floats, because 2 as an integer is the same thing as 2 as a float, but 2.5 as a float is different than 2.5 as an integer. So if you want to be safe and just assume it could be a whole number or a fraction, but it doesn't matter, you can just convert them all to floats.
And to do that, you would just do a float and then
Yeah.
put the variable.
Yeah, and then you put the variable inside the parentheses there, and we'll convert it to a float. Yeah.
Okay. So I'm putting in an exponential, so times n times, oh wait, one second, let's see if it works.
Running in the command line.
24, yeah, it's still giving me invalidable for float, but when I do it for integer, it gives me the same error. I went on Stack Exchange, I have to figure it out.
So, oh, you're trying to,
Put in that number. There are 7 times 10 to the 24 stars in the universe.
so you're trying to do the computation in the input.
Yes, well, not exactly.
So, here, let's take a look at why this is great. So let's break it down. So you ask how many stars are in the universe, right? And you give it in that input for stars, right?
Yeah.
So let's go ahead. Does it matter if you go on to the next question?
No, but
Oh, that's because you can convert it to float right now. I'm gonna break out this float real quick. Okay. Let's take the input first, and then we'll float it into something else. Let's just go ahead and print. And then you can do the conversion afterwards. So this is just gonna let us see what's happening. Like, as it comes in from the input, we'll see what it's taking in.
yeah,
And then we'll see what it's trying to convert to a float. We can just go ahead and run that again. So see, right before it crashes, it's printing back this float. So this is what it thinks stars is. Let's go ahead and get a little closer to what I'm trying to do.
I know the problem is. It's fine.
So when it takes in this expression in input,
Yeah.
it's taking this whole thing as a string.
Okay.
So as a string, then and a string doesn't know. When you try and convert it to a float,
I
it's
see.
like, what? This is not a number in here. There's
Alright.
some stars in there.
Yeah. So since it's not actually carrying out an operation, then I can't convert it. Okay.
Exactly.
I'll fool around with some more. The entire thing works. I just want to
Yeah.
play around with it.
You parse out the input if you want.
Yeah, I could, but.
Yeah, that looks like you're getting the right stuff. You might want to have like a print statement that says, like, this is the number of civilizations. This is the number of intelligent civilizations. Or sort of like explain a little bit about what's going on. But technically, you got everything. Okay. Yeah, that was right. So we're getting, some people are getting close to done. How many people are like done? A few? How many people are like close to done? All right, and everyone else is still working on it? Good. So I hope this is a good exercise. We're getting towards the end of class here. I want to mention real fast that Lab 3 is open on the website. It's similar to what we've been doing in class here today. It's sort of got a similar sort of feel to it, but with some extra little quirks and conversion stuff that we're going to have to work on. We're going to be working on Lab 3. Pull up the website. We're going to be working on Lab 3 in class tomorrow. And that's what we're going to be doing tomorrow. It's about orbital rotations, time it takes to go around the sun, that sort of thing. So we're going to be working on that in class tomorrow. I'd suggest you try and finish up your Drake equations before class tomorrow. It's going to help you out a lot. And if you get done with them, feel free to take a look at the lab and come with questions for next time. All right, any other questions, comments, concerns before you go? Excellent. Good work today, everybody. Yeah, you too.
Nice, you can steady.
Yeah. Kind of fun. Although we ran into the issue of we don't really know what numbers to put in for. We're just kind of like, we don't know.
One of the big questions people ask is, where the hell is everybody? Right?
Yeah.
Well, many of these are on zero. You think
Well, what I was reading in the article was like, we can't actually calculate some of these because they're just like, how are we supposed to know? So it's like, the equation is really more of like a thought exercise than anything else.
although it's interesting, this stuff is particular. We have much more. When I did this for freshman in college, we didn't know any other planets. Right now, they've actually seen planets.
Yeah.
They've seen a lot of them in the last 10 years. So they at least have some sense of, oh, well, I guess it's this one.
Yeah. We actually know more about like stars and
Yeah.
There's quite a few, like, this is the first conversation I've seen classes.
Yeah, that's what you're gonna do. Yeah. That's right, because you said you're gonna do it. Yeah. Exactly. Yeah, I know this is good.
it's all coming together.
We know this one pretty well, we know this one kind of well, we know this one, the rest of them.
So that's the thing, when I saw this in 76,
Everywhere we look.
exactly, yeah.
You know, which.
And we can almost see really big ones right now, yeah.
I mean, actually, we can see Earth-sized planets.
Are they really?
Earth-sized